A crossbow fires a ping pong ball at a certain angle with the ground. The ping pong ball then lands at a distance. Question. Determine the initial velocity, maximum height, and the hanging time of the ping pong ball if the angle is at 20 degrees with a distance of 2.93 meters. The angle is at 40 degrees with a distance of 3.13 meters. And the angle is at 60 degrees with a distance of 2.79 meters.
This is the illustration to the problem given. We have here the three trials in which we fired our crossbow. Trial 1. Angle 20 degree. Range 2.93 meter. Trial 2. Our angle is 40 degree. Range 3.13 meter. Trial 3. Our angle is 60 degree. Our range is 2.79 meter. Next, we proceed with the solution. Trial 1. Given. Our angle here is 20 degrees. Our range is 2.93 meters. So first, we find the velocity. So we use v squared equals initial velocity squared plus 2 times a times delta x. So 0 equals initial velocity squared plus 2 times our acceleration here is negative 9.8 meter per second squared times our range is 2.93 meter. So the result is 57.428 meters squared second squared. Then square root both sides and we'll get the answers. Our initial velocity is 7.58 meter per second. Next is we find the horizontal initial velocity. So we use horizontal initial velocity equals initial velocity times cosine theta. So we simply substitute. So our initial velocity here is 7.58 meter per second squared times cosine 20 degree, which is our angle. So we find the answer. So our horizontal initial velocity is 7.12 meter per second. Next, we find the vertical initial velocity. So we use the formula. Vertical horizontal velocity equals initial velocity times tan theta. So we simply substitute. So our initial velocity here is 7.58 meter per second times 20 degree, which is our angle. And so we get the answer. Vertical initial velocity equals 2.59 meter per second.
To get the maximum height, we need to use the equation final velocity y squared equals initial velocity y squared plus 2 times acceleration times delta y. Substitute and we'll get 19.6 meter per second squared times delta y equals 6.7081 m squared s squared. Divide both sides by 19.6 m s squared and you'll get 0.34 meters. That is the maximum height. And in solving time, we need to use the equation initial velocity x equals delta x over time. Substitute 2.93 meters divided by 7.12 meter per second and we'll get 0.41 seconds.
Good day, guys. So in trial 2, the ping pong ball is fired from the crossbow at 40 degrees with the ground. It travels a distance of 3.13 meters before it hit the ground. So here, we solve for the initial velocity, including the x and y components in this projectile motion. So for the initial velocity, we have v squared is equal to vi squared plus 2a delta x, where v is the final velocity, vi is the initial velocity, a is the acceleration, and delta x is the range or the distance. So we substitute the values. 0 is equal to vi squared plus 2 times negative 9.8 meter per second squared times 3.13 meters. So here we get the answer, which is initial velocity is 7.12 83 meters per second. So we solve for VIY. VIY is equal to VI sine 40 degrees. So this compute answer will be 5.03 meter per second. And to solve for VIX, we have 7.83 cosine 40 degrees. And this will be 6 meter per second. To solve for the maximum height, we will use the formula final y velocity squared equals initial y velocity squared plus 2 multiplied by acceleration times delta y, which is the maximum height. Vfy squared is automatically 0 because the velocity is 0 at maximum height. The acceleration would be negative 9.8 meters per second squared because the ping pong ball is acted upon gravity. So, let's substitute the given values to the formula to find the maximum height. 0 equals 5.03 squared plus 2 times negative 9.8 times delta y. We'll get 25.3009 minus 19.6 delta y. Transpose 19.6 delta y to the other side and divide both sides by 19.6 so we can get our final answer, which is 1.29 meters, and that is our maximum height. To solve for the hang time of the ping pong ball, we have to derive the formula Vix equals delta x over t. Cross multiply and we'll get t equals to delta x over Vix. Delta x would be 3.13 and Vix is 6. So substitute the values, 3.13 divided by 6, and we'll get 0.52 seconds, our hang time.
Trial 3. Given, angle is 60 degrees, x is 2.79 meters. Then final velocity equals to 0. First, we need to solve the initial velocity using the equation v squared equals vi squared plus 2ax. Substitute all the given, we can get 0 equals vi squared plus 2 multiplied by negative 9.8, then multiplied by 2.79. Move vi squared to the other side, may mo siyang negative vi squared equals negative 54.684. Divide the negative sign, then we can get vi squared equals positive 54.684. Square the both sides. Initial velocity equals 7.39 meters per second. Then we need to solve the VIY using the formula initial velocity sine theta, substitute, equals 7.39 sine 60. The answer is 6.40 meters per second. Then Vix using the formula initial velocity cosine theta, substitute 7.39 cosine 60 equals 3.70 meters per second.
To solve for the maximum height, we have the formula final velocity y squared is equal to initial velocity y squared plus 2ay delta y. Simply we substitute the values. 0 equals 6.3999 quantity squared plus 2 times negative 9.8 delta y equals 40.9587 minus 19.6 delta y. To change the negative sign of delta y, we move it to the other side. So 19.6 delta y is equal to 40.9587. To remain the delta y, we divide both sides by 19.6. Delta y is equal to 2.0897. Therefore, our maximum height is equal to 2.09 meters. To find the hanging time of the ping pong ball, we derive from the formula initial velocity y is equal to delta x over time. Time is equal to delta x divided by the initial velocity y. Equals 2.79 divided by 3.70. Therefore, the hanging time of the ping pong ball is equal to 0.75 seconds.
The maximum height and time of each trial is getting larger as the measure of the angle increases. Then, in trial 2, which has an angle of 40 degrees, has the greatest range and initial velocity. If we compare the total time for each trial, trial 3, which is 60 degrees, has the most time consumed, and it also has the greatest maximum height. In our table, we have here the 3 trials. In trial 1, we have an angle of 20 degrees and a range of 2.93 meter, and our maximum height is 0.34 meter. In trial 2, our angle is 40 degrees, the range is 3.13 meter, and our maximum height is 1.29 meter. In trial 3, our angle is 60 degrees, the range is 2.79 meters, and its maximum height is 2.09 meter.
Summary. A projectile is an object that is under the sole influence of gravity as it rises and falls. A projectile motion has both vertical and horizontal components. As the angle is increased, the maximum height and flight time of the object is also increased. Mass is not relevant in projectile motion. The angle that gives a maximum range is at 45 degrees. Beyond that angle, the range decreases. That's why the range at 40 degrees is greater than the range at 60 degrees.